Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. EBML 2103 Engineering Materials. My presentation is about copper buildings. My name is Khairul Anwar bin Muhammad Yusuf, Applied Science, Bachelor of Science in Project and Facility Management with Honor, semester September 2020. Introduction about copper. Copper is a chemical element with the symbol Cu from Latin cuprum and atomic number 29. It is a soft, malleable and ductile metal with very high thermal and electrical conductivity. A freshly exposed surface of pure copper has pinkish orange color. Copper is used as a conductor of heat and electricity, as a building material and as a constituent of various metal alloys, such as sterling silver used in jewelry, copper nickel used to make marine hardware and coins, and constantan used in stirring gauge and thermocouple for temperature measurement. Commonly, a counter compound of copper to salts, which often impact blue or green color to such minerals as azurite, malachite, and turquoise, and have been used widely and historically as pigment. Copper used in buildings, usually for roofing, oxidized to form a green verdigris or patina. Copper is sometimes used in decorative art, both in its elemental metal form and its compound as pigments. Copper compounds are used as bacteriostatic agents, fungicides, and wood preservatives. Copper has earned a respected place in the related field of architecture, building construction, and interior design. From cathedrals to castles and from homes to office, copper is used for a variety of architectural elements, including roof, flashing, gutter, downspout, domes, spires, walls, wall cladding, and building expansion joint. The history of copper in architecture can be linked to its durability, corrosion resistance, precision appearance, and ability to form complex shapes. For centuries, craftsmen and designers utilized this attribute to build aesthetically pleasing and long-lasting building systems. For the past quarter century, copper has been designed into a much wider range of buildings, incorporating new styles, varieties of colors, and different shapes and textures. This is for example building using copper materials. Number 1, office building at Mongshan Road, Hangzhou, China. Number 2, Evangelical Lutheran Church of Bavaria. Number 3, Museum of Fire, Zurich, Poland. Number 4, Penn State University School of Architecture and Landscape Architecture, Sala Building. First example, office building at Mongshan Road, Hangzhou, China. The 10-story office building is located in a diversely building area on Mongshan Road near Hangzhou Tranquil Shuihan Park. Within this dense content, the new building asserts its object-like presence with a clear geometric form. The positioning of the slim building in the middle of the site provides spatial distance to the neighboring buildings. Placed above street level, the volume sits as if on a stage. Together with the modulation of the surrounding exterior space, the raised level allows for diverse transition from the city into the building. Also, all stone surfaces of the exterior topography are crafted from the same matte grey basalt. The structure of the building is based on a reinforced concrete frame. The facade is clad with large copper cassette reflecting the structure outwards. Smaller sheet copper elements clad the area around the windows. These smaller elements, which are manually pointed using a standing seam technique, display a degree of refinement and accentuate the surfaces within the overall structure. The rectangular column along the narrow side of the building enhances the slender appearance, and the leafless surface of the bronze cladding gives the facade an elegant, vibrant look. Second example, Evangelical Lutheran Church of Bavaria. For left, front view, and right as a 3D view. Copper wall will gradually change color from dark gray to rich brown on the exterior of this church archive in Nuremberg, Germany. The seven-story structure houses the archive of the Evangelical Lutheran Church of Bavaria and is located close to the main church building on the site of a former factory. The design of pinkish sandstone plinth for the base of the building. This allows it to nestle against the side of a hill as well as to fit in with its neighbor. A glazed ground floor is sandwiched between this plinth and the copper-clad upper floor, which comprises two overlapping block-like volumes. The plinth of the reinforced structure is clad with reddish sandstone, which form a continuation of the existing sandstone wall and anchor the building in the landscape context. The external walls of the archive are finished in a shiny copper facade with a subtle vertical structure. The oxidizing copper panels are arranged vertically and interspersed between narrow metal stripes. Alternate panels extend down over windows, creating the appearance of columns. The natural metal surface will undergo various oxidation stages and color change until it finally develops a velvety brownish appearance. Third example, Museum of Fire, Zori at Poland. On the left, external wall view, and the right, internal decoration walls. The Museum of Fire has been created where its primary function is to promote the municipality. The small structure has arisen at the edge of town and acts as a landmark, indicating to people that they have just entered Zori. This unusual building, the Museum of Fire, resembles a flame creeping along the ground. The pavilion comprises three wavy walls joined with glazed sections, forming a sculpture-like composition. It has been developed on an embankment, making it highly visible from all directions. Architects Barbara and Oskar Grabowski have broken, folded, bent, and cut its body in such a manner that it represents the natural behavior of fire. The association with fire enhanced by the copper facade which trigger an impression of burning fire when shimmering in the sunlight. Not only does the copper lend a fiery color, but having been polished, it shines brightly and reflects the surroundings. If the copper were left exposed to the element, it would oxidize and patinate, eliminating the fire effect of the copper. This problem was solved by the manufacturer of the copper sheet who proposed method to prevent patination of the copper. The copper facade has been painted with a special varnish, similarly to that used on a car body. The transparent varnish secures the shiny polished copper surface, preventing it from patinating, thus ensuring the natural concrete walls are used inside the building where one will find a number of exhibition rooms that have unusual forms. The building holds multimedia exhibition demonstrating scientific aspects of the natural phenomena which surround us. It is modern in form and architecturally uncompromising design for people curious about the world. The younger ones predominantly, but it still escapes artificial divisions. Fourth example, Penn State University School of Architecture and Landscape Architecture, Sala Building. On the left, the copper cladding used the traditional flat seam technique to tie the building into its more traditional surrounding. And the right depicts pre-patinated copper-clad facade complement the existing surrounding. The south elevation is articulate with sunshade and deep windows. From the beginning of the project, there was a clear commitment by all involved to practice what they teach and to achieve a LEED silver rating at a minimum. With this goal in mind, the designer used the aspects of sustainability to consider all of the issues around the building, including its seating, envelope, system, and materials. They made extensive use of computer modeling in the design phase to consider the impact of different design and material choices on the performance of the building. For instance, the design called for the building to be as transparent as possible. However, the more glass one uses, the greater the glare and heat fluctuation within the buildings. By using copper sunshade, the designer were able to maximize the use of glazing while minimizing the downside of its use. The computer modeling also helped them to optimize the envelope, lighting, and mechanical design, as well as to minimize the building's energy. More than 30 tons of copper is used throughout this project. Most noticeably, 90% recycled copper is used in the 49,000 square feet of pre-patinated claddings. From the exterior surface to the plumbing under the floor, copper contributes to the building's financial and environmental performance. Throughout the project, copper was considered a good material choice due to its recycled content, the high rate of recyclability at the end of its use in the buildings, its local availability, low or non-existent maintenance costs, and its durability. Further, the project called for a sculpted exterior to fit with its traditional surroundings, and copper proved to be the ideal material to work it with. The copper cladding demonstrates attainment of both material performance and aesthetic objective. The cladding used traditional flat seam technique to tie the building into its more traditional surrounding and the older campus building close by. Copper's flexibility allowed the designers to use the amount of glazing desires, while minimizing the glare which can often accompany it by manipulating the copper to create vertical and horizontal sun shading. The shading minimizes glare and also reduces temperature variation within the building. To maximize the low maintenance benefit of the cladding, copper was used for all of the soffit and sunset. Over the building's life, copper limited maintenance requirement and exceptional durability will translate into substantial cost saving and will avoid environmental impact from cleaning and replacement. Another unique use of copper is on the ceiling of some of the largest atriums. This provides an attractive accent to the rest of the gypsum ceilings. While there was some concern about the higher upfront cost of copper, the industry and designers look hard at the long-term cost implication of their material choice. The positive result ensure copper prominent roles. The building also earned a credit for use of local and regional materials because 87% of its materials were harvested within 500 miles of the campus, including the copper. Further, by allowing the designer to achieve their goal of maximum visual transparency without glare and temperature drawback, copper contributed to the achievement of a LEED credit for daylight and views. Sekian, terima kasih.